Yes, I see you have your hand raised, Eugene. Do you have a question? Okay, so we are on Unit 10, and the topic is dependable systems. We will cover the following learning outcomes. So, have an ability to identify, analyze, and evaluate why dependability and security are important attributes of all software systems. Evaluate and apply 5 dimensions of dependability to all software systems. Have a thorough understanding of socio-technical systems and justify why they have to be considered. Demonstrate and analyze why redundancy and diversity are fundamental concepts of achieving dependable systems, and justify the potential of using formal methods in dependable systems engineering. So when you talk about the aspect of a dependable system or dependability, what is dependability? And dependability is a measure of a system's availability, reliability, safety, security, maintainability, and performance. We can look at these as the nature of the non-functional requirements, right? So these are the common attributes that you look out for when you're measuring how effective a system is. So they also say that dependability can also be defined as the ability to provide quality services to users when needed, and dependability of a system should reflect trustworthiness. So when you are thinking of using a system, this we all look for certain things, okay? And those determine whether we trust the system or not. In some cases, some people look at how the way the system looks and immediately they pass a judgment, which is not necessarily a good way of looking at it. Remember, they say don't judge a book by its cover, but so it doesn't really matter how the system actually looks to some extent, but the most important attributes are those mentioned as availability, reliability, safety, and so forth. So undependable systems may cause information loss with a high consequence recovery cost. So your system may look good, but if these non-functional requirements are not met, then it could result in information loss, which is very expensive to recover from. So dependability of a system is important for all software systems because of the following reasons. It's important to make sure that the system is strong and dependable because of these reasons. So system failures affect a large number of people. When a system goes down, a lot of people are affected. A lot of people's lives come to a standstill. You can imagine if the bank's system had to go down, people won't be able to go and withdraw their money and so forth. So it's very important to consider these aspects of dependability and how we can go about measuring dependability. So users often reflect systems that are unreliable, unsafe, and unsecure. So these are some of the things that cause end users not to actually trust systems or not want to use systems. If a system fails, the cost to repair and recover may be high. Okay, so prevention is better than cure. So if you built it right the first time, then you won't have to incur the costs later on of having to do damage control and repair and so forth. So this issue of availability, if we look at it closely, we can say that safe system operation depends on the system being available and operating reliably. I think availability is one of the most important aspects in the attribute of dependability. And it can be compromised, of course, through attacks. And we try our best to reduce these number of attacks. And some of the common external attacks that we get against systems is denial of service. okay, where an attacker would flood the server with multiple requests until the server crashes. So that's one of the aspects that may affect the system's availability, okay? And of course, if a system is infected with a virus, you cannot be confident in its reliability or its safety, okay? And we can see in this diagram, the 5 dimensions are also further mentioned. So you can see availability, what they say, the ability of a system to deliver services when requested. You need it now, and it's available now, not later. Reliability, the ability of a system to deliver services as specified. So you're performing a transaction, you want the transaction to complete successfully and accordingly to how you had initiated it. Safety, the ability of a system to operate without catastrophic failure. And the aspects you may be asking yourself to some extent, what would be the difference between safety and security? Safety is more on the side of, could the system cause harm to into the environment or to people, to individuals, okay? And security obviously is on the side of protecting against intrusion, whether internal or external attacks on the system. Then we also have resilience, the ability of the system to resist and recover from damaging events. So having some contingency plans or recovery mechanisms, making use of RAID and so forth to back up the data. So these are the 5 common dimensions, but there may be other ones that, they may be, I told you guys before, that functional requirements actually branch out. So there may be other ones as well that people may use as a factor, a measuring factor to measure dependability, but we can agree that these are the most common ones. And you can see based on this curve that the more, the higher the dependability, the level of dependability, the more expensive the system will be, because there'll definitely be an extra amount of rigor in developing it. You're going to implement additional steps or standards. So we find that systems with ultra high level of dependability are the most expensive. We find these maybe military grade systems, aviation systems, banking systems that control ATMs, systems that control the lift, and so forth. You need high dependability there because people's lives are at stake. So the aspect of dependability itself is a subjective one. And what this means is that you can't really force people to have a particular view on how to measure dependability. We may have the 5 dimensions, but certain ones, people consider certain ones more important than others. Okay, so it's based on your opinion. What are you looking out for? And they say that the dependability of a system is not obsolete, but depends on the judgment and expectations of a system stakeholder. What seems to be a system failure to one stakeholder is normal behavior to another. So another stakeholder may say, on the aspect of, it may sound bizarre, but they may say, on the aspect of security for this type of system, I don't really mind, for as long as it's always available when I want to use it. So the person would have their own justification for such reasons. So they're willing to compromise security for as long as availability and reliability are always there. Okay, so it's a very subjective thing. As you can see here in terms of this slide, user expectations matter. A banking system that does not update user accounts in real time, but queues the transactions and updates accounts twice a day. A user that expects real-time updates may consider this undependable, and as they cannot be sure whether or not the account balance is accurate. So people are very judgmental based on their own personal views. And the system was built to, I think maybe it could be an aspect of efficiency, that you didn't want the system to update transactions every single time they occur because it's going to compromise the system's performance. So the people who built the system had good intentions when they were building it because they tried to improve its performance. But another user will see that as a liability to say, wait a minute, why are the transactions only updating at the end of the business day? Therefore, I cannot trust the account balance on this particular banking system. So other factors that are closely related to these dimensions as well, apart from the 5 dimensions we spoke about, also repairability. If there is a component which has failed, it should be possible to diagnose the problem and then fix the component or solve the current problem. So we also look at the aspect of repairability and how soon can this system be repaired, or how fast can issues be repaired? We can all agree that obviously we expect repairability affects availability, because when we have downtime, we want the issue to be solved immediately for mission critical systems. And also the aspect of maintainability. Changes can be introduced to new requirements, and all the changes made to a system must bring value to a system. Okay, so then there has to be a plan on how to maintain the system. Okay, and error tolerance as well. This is the extent to which the system must tolerate and avoid certain errors. Also, in the aspect of error tolerance, we say the system should have some sort of error handling. You don't want for every wrong input, the system is crashing. You want the system to generate some sort of error for the user, some error message, some user-friendly error message that says you have clicked, or you didn't put particular input, or the resource that you're looking for is unavailable, and so forth. So it needs to be considered. Okay, to develop dependable software, the following needs need to be considered. During the system specification and development, accidental errors must be avoided or reduced. And obviously, one way of doing this, they say that during system specification and development, accidental errors must be avoided or reduced. One way of doing this or avoiding this is by choosing the correct software development lifecycle. So it's not, I wouldn't say it's a smart idea to develop a dependable system using a waterfall approach, because one can imagine that this is something that needs a lot of iterations. It's an iterative process. So for you to avoid or reduce the amount of accidental errors, it means you have to go in circles and sometimes repeat certain processes that you've already initiated. So the spiral model and the V&V model would be a good approach if you need to develop a system that is dependable. So during verification and validation process, residual errors can be discovered. This is an effective way of identifying and discovering errors. So here also they're hinting in the next point that the fact that you may be using the verification and validation process, where in the one direction, you're trying to understand the nature of the specifications, and in the other direction, you're dealing specifically with testing that reduces errors or bugs. Okay, so the V&V model is what they're hinting here would be a good one in terms of dealing with errors. So design a system which is fault tolerant, even in the event of failure. Systems must be capable of recognizing external cyber attacks and must resist to these attacks. Okay, so the system must be able to fight back to some extent, because there are a lot of cyber attacks out there. So moving on to the next point, which is socio-technical systems. And when you talk about socio-technical systems, talking about systems that consist of both the human element. The success of the system is based on the nature of the relationship between the human aspect and the technical aspect of things, or the IT. So these two have to balance each other. We have to have people that are well educated in terms of how to use the system and understand the system well, not people who resist the system and so forth. And also on the technology side of things, you have to be up to date. Your infrastructure has to be up to date. So it consists of obviously multiple layers, which is the equipment layer, the operating system layer, the communications and data management layer, and also have the application layer. It continues with three other layers. So when you're talking about equipment layer, it contains all the equipment to be used by socio-technical systems, includes hardware devices. And as I said, you want the system to succeed based on all of these layers. So make sure each layer has the recent or most updated devices, especially when you're talking about equipment layer. We want the latest hardware. In terms of operating systems as well, we want the latest operating systems. In terms of communication and data, we want the latest or the most professional methods of initiating communication or sending data or sending messages. And one way would be of, they mentioned that this is the middleware layer, which provides interfaces and facilities to send to the operating system. So you can see here that when they say middleware layer, they're talking about the fact that the system must be able to communicate also internally with itself in different platforms using layered architecture. And also application systems, it provides specific tasks or functionality, which will be required by the system. So make sure that you have the latest applications that the end users can use in the environment to make changes to the data structures or to the databases. Then also we have the business processes. This layer contains all the organizational business processes which are used by the system. And we said that in the previous study unit that most organizations obviously build their softwares on top of their business processes. So the business processes are integrated as part of the systems, and without the system there, then the organization cannot perform its work or do its work. So we need to make sure that those. And in terms of the organization, then yes, the people inside the organization, business rules, your policies and procedures are stored at this level, and it needs to be understanding with the people in the organization as to what expected in terms of the rules and the policies, and society as a whole. So this is, you can look at it as people outside the organization, your customers, your suppliers, and so forth. And this is just the diagram version of the previous slides. How would it look like in terms of layers? The first layer would be obviously the equipment layer, and then it goes upwards to the society as a layer. So the dependable processes, these are processes designed to produce dependable systems, and they should have fewer errors and less likely to fall in execution. Documentation and appropriate development techniques are used on these dependable systems. So part of certain things has to be part of your processes when building a dependable systems. One of them is making sure there's proper documentation, the system is properly documented, okay? And dependable processes make use of redundancy and diversity to achieve reliability and availability. Making sure that there's proper backups, and in terms of diversity, how do you accommodate for different users? Some users may want to use the system using a web browser. Some users may want to use the system using their mobile device. So diversity is also one of the aspects, most important aspects in redundancy. So dependable processes are also auditable, diverse, documentable, robust, and standardized. Attributes for some of the dependable processes. So the processes that yield a dependable system have to be able to also measure they also contain certain attributes which you can measure them for or by rather. We say they have to be auditable, they have to be diverse and documentable, robust, and standardized in line with industry standards. I mean, you can imagine you cannot say you're building a dependable system and then you're not following, for example, industry standards. There's industry standards for building a system such as a lift. So you can't innovate there or use your own standards. You have to use industry standards. So this is just some of the attributes that you look for out of a dependable process that produces a dependable system. And then the last concept you want to talk about is formal methods. So formal methods are basically a mathematical way of representing a system. It just adds that extra layer of clarity by making mathematical models apart from your graphical modules, your use case diagram, and so forth. Also writing some sort of mathematical formulas, which we refer to as formal methods or formal models, is a good way of making sure that there's mutual understanding. And they say that according to Somerville, formal methods are defined as mathematical approach to software development, where a formal model of a software is defined. A formal model is used to search for errors, inconsistencies, and even prove that the program is consistent with the given model. You know, they say people that are very quantitative, they believe in numbers, and numbers do not lie. And numbers have always existed, and mathematics has always been part of engineering. When people are building bridges and they're building houses, you do some sort of calculations, and they provide you with some level of certainty that what you're actually building and the way you're building it will actually work. So software engineering also is no different as a field of engineering. To say that by using mathematical models, you provide some level of assurance. So using formal methods during software development results in a system with the fewer errors during execution. And so in summary, this unit covers the 5 dimensions of dependability of a dependable system, which we mentioned are availability, reliability, safety, security, and resilience. And they also talk about socio-technical systems that are designed to support organizational business goals and objectives of a system. And these systems motivate for the collaboration between, or mutual understanding between the people in the organization and the technologies that they use. Redundancy and diversity enhance dependability on a software system since redundant copies of data and information is created. That's also part of the dependable process. So diversity decreases the chances of a system or component failure, since diversity creates redundant components of the system, which are different types. Finally, formal methods are used to search for errors and inconsistencies, which in turn supports dependability. So the last study unit, it's more based on real theory. Really, there's not a lot of diagrams there, and it's very short. Okay, so we are now done with all the study units, and we can proceed from next week doing our